Welcome back everyone to another video. So today we'll be going through the 2019 Mathematics Standard 2 HSC. Just as a reminder, as always, so make sure to allocate your time correctly. So there's 100 marks in this examination and you have 2.5 hours. So I would recommend having around 90 seconds per mark for each question that you're looking at. Okay, so let's get started on the first section, multiple choice. So which of the following shapes has a perimeter of 12 centimeters? So let's just go through each. So 2 centimeters, 4, that's 6, and then times by 2. So actually our first option A is going to be the correct answer there. We don't even need to check the rest. Question 2. Sugar is sold in 4 different sized packets, so which is the best buy? So what I'd recommend doing here is to bring everything either down or up to a common factor. So for me right now I might say let's bring everything up to 2 kilograms. So for part C, well, to get that to 2 kilos, I'd have to times that by 2. So 350 times 2 is going to be $7. For part B, 500 grams goes into 2 kilos 4 times. So we'll times 1.65 by 4. That's going to be 660. And for part A, 100 grams goes into 2 kilos 20 times. So 40 cents multiplied by 20 gives us $8. So our option here will be B for the best rate. Okay, part 3. So Chris opens a bank account and deposits $1,000 into it. Interest is paid at 3.5% per annum, compounding annually. So assuming no further deposits or withdrawals are made, what will the balance be in the account at the end of 2 years? Okay, so we've got all that information there. So let's quickly think about our compound interest formula. So we know that A, the final amount, is equal to P, the principal. So here that was $1,000 times by 1 plus an R, our interest rate is 3.5% per annum, so we can just write 0.035. And then that's going to be all to the power of, well, how many years? Simply 2 years. And that's going to give us our answer here. And so when we actually calculate that, we'll get a final value of B. And so just a quick reminder of our compound interest formula. It should go as follows. So A equals P, 1 plus R over N, all to the power of NT. So R is your interest, P is the principal, N is the number of times per year that it compounds, and T is the number of years. And then A is your final amount, as we've just looked at there. Okay, part 4. So which compass bearing is the same as a true bearing of 110 degrees? So let's think about what that looks like. So that looks like this. So if I have a northeast, southwest, oops, there we are, west and south. So 110 degrees, that means we go all the way around, so that's 90 there, and then would go 20 further. So a line around here. Okay, so now what is the compass bearing of that? So if we start going through our answers, well, south 20 degrees east, no, that would be going 20 degrees east from south, so that won't quite cover it. What about south 20 degrees west? Certainly not that. And then part C, south 70 degrees east. So that means we start at south and go 70 degrees east. And yes, that will give us our answer there. So option C is the correct solution. Okay, part 5. So the coordinated universal time of Auckland is plus 12 hours, and the coordinated universal time of Chicago is minus 5 hours. So when the time in Chicago is 2 p.m. Thursday, what is the time in Auckland? So first of all, what I'd recommend doing generally for these types of questions is always start thinking in 24-hour time. So if it's 2 p.m. in Chicago, that means it's going to be 1400. Okay. All right, so now what's the actual difference? It's going to be from 12 down to minus 5. So that's a difference of 17 hours. So Auckland is 17 hours ahead of Chicago. So if it's 2 o'clock or 1400 on Thursday, what is the time in Auckland? Well, we don't actually need to worry about the numbers here because we know if it's 17 hours ahead, it's clearly going to be on Friday. And our only option here, with Friday in it, is going to be part D, 7 a.m. Friday. Okay, question 6. So Mary is 18 years old and has just purchased comprehensive motor vehicle insurance. The following excesses apply to claims for at-fault motor vehicle accidents. So we have a basic excess of $850 for each claim, an additional age excess for $1,600 for drivers under the age of 25, an additional age excess for $400 for drivers 25 years of age or over with no more than 2 years driving experience. Okay, So how much would Mary be required to pay as excess if she made a claim as the driver at fault in a car accident? Okay, so she's 18, so what we're assuming there is that she's been driving since she was 16, so that means she's been driving from 16, 17, and now she's 18. So we can see that she's already got more than 2 years of driving experience. So we can go ahead and cross out that last option there, because that will not have any reason to be included here. So what else do we know? So basic excess of 850, that must be included, an additional age excess of 1600 for drivers under the age of 25. So yeah, so it's going to be option C, because it's going to be both of those combined. Okay, part 7. So Julia earns $28 per hour. Her hourly pay rate increases by 2%. So how much will she earn for a 4-hour shift with this increase? Okay, so what we can do here is we can actually just say $28 times by 4 and then times by 1.02, because 1.02 represents an increase of 2% or 0.2. And when we calculate that, we get our answer of $114.24. Okay, part 8. So a person's weight is measured as 79.3 kilograms. So what is the absolute error of this measurement? Okay, so absolute error, just a reminder, means you go 1 decimal place over and then you let that section be a 5. So if we look at it a little bit easier, whoops, that's a 3. So what we would do is we'd say, okay, we're going to go over 1 more digit. So we've already got 0.0 and we go over 1 more. So we're in this column here and we let that be a 5. So that is our absolute error here. And so if we're talking about kilograms, so 0.05 kilograms, what does that correspond to? Well, that's going to give us 50 grams. Okay, question 9. So what is the interest earned in dollars if $800 is invested for X months at a simple interest rate of 3% per annum? All right, so simple interest formula, let's have a quick think about that. So it's I equals P R T. Some people put N, some people put T, doesn't really matter. So if $800 is invested for X months at a simple interest rate of 3%, what is the interest earned? Okay, so we know the principal, and we know the rate, and we know T is X months. So that will give us I equals 800 times by 0.03. But here we've said X months. Okay, so the key here now is to say times by X divided by 12. And so what happens there is we then compute that. So 800 times by 0.03 times by, we'll just say 1 over 12. And the answer that we get is going to be A, 2x. And there we go. So that's our answer there. Alrighty. So, part 10. A school collected data related to reasons given by students for arriving late. The Pareto chart below shows the data collected. So it asks us what percentage of students gave the reason train or bus delay. So first we want to identify where that is. So that's in this column here. And so we're not going to actually be looking at the columns for our percentages. We're going to be more concerned with the line graph here. So what this shows is the cumulative frequency. So what we're looking at here is going to be the distance between this point and this point down here. So that's a difference going from around, I'd say, 92% to 85%. And so then we have a look at our options, and well, the closest one to that is going to be 6%. And there we are. So that's just the difference from here down to here. Okay, question 11. So which of the following correctly expresses y as the subject of the formula 3x minus 4y minus 1? Okay, so we can quickly solve for y, so I might add 4y to both sides, then we'll have 3x minus 1 equals 4y, and now we'll divide both sides by 4, and then we can rewrite it as y equals 3x minus 1 all over 4, and that gives us option C. Okay, question 12. An owl is 7 meters above ground level in a tree. The owl sees a mouse on the ground at an angle of depression of 32 degrees. So how far must the owl fly in a straight line to catch the mouse, assuming the mouse does not move? Okay, so we want to quickly draw a diagram for this to make our lives a lot easier. we are. So it's a right angle triangle, and we know that the owl is 7 meters above the ground. So we'll say there they are at 7 meters. Now it's an angle of depression of 32 degrees. So we can't forget that an angle of depression and an angle of elevation always begin from the horizontal. So what that means is that this angle that's being measured is actually this angle here. So that there is 32 degrees. Okay? And so that means, therefore, that this angle here is 32 degrees. And so now we are asked, how far must the owl fly in a straight line to catch the mouse, assuming the mouse does not move? So that's just going to be the length of the hypotenuse. So we know our angle here, and we know the side length over here. So we can just use our SOHCAHTOA. So perhaps we could say sine of 32 is going to be equal to 7 over the hypotenuse. And so therefore we can rearrange, and we find that the hypotenuse is going to be equal to 7 meters divided by sine of 32 degrees. And when we calculate that, we find that we have a value of about 13.2 meters. Okay, question 13. This one's actually a little bit tricky. So the graph shows the future value over time of $1p invested at 3 different rates of compound interest. Okay, so which of the following correctly identifies each graph? So we have W as 5% per annum compounding annually, X at 10% compounding annually. So right off the bat, we know that that is incorrect because we see that W is above X. So we know that that makes no sense if we have a larger percentage interest on X. So it makes no sense whatsoever. So we start looking at part B. So it says 5% per annum compounding annually for W, then 10% per annum compounding quarterly. Okay, and Y is 10% per annum compounding annually. So if we look at this, well, we see that, first of all, W and Y are very clearly the incorrect way around, if that's to be what they are described by. So 10% per annum is obviously going to be greater in terms of your returns than a 5% per annum if they're both being compounded annually. So it's not going to be B for that reason there. We now look at C. So 10% per annum compounding quarterly for W, then 10% per annum compounding annually for X, 5% per annum compounding annually for Y. And that actually sounds about right, because we know that the more often you compound the interest, then the more income you will actually return from that investment. So we know that it makes sense for W to be above X if W is compounding quarterly and X is being compounded annually if they have the same interest rate. And then for Y to have a 5% per annum compounding annually, yeah, it kind of makes sense that that would be a much more slow growth. So our answer here is going to be C. Okay, question 14. So last Saturday, Luke had 165 followers on social media. Reese had 537 followers. On average, Luke gains another 3 followers per day, and Reese loses 2 followers per day. So if X represents the number of days since last Saturday, and Y represents the number of followers, which pair of equations model this equation? So model this situation. So let's look at Luke first of all. So let's say Y is the total number of followers. So Luke, we'll say Y sub L. That's going to be equal to, well, he starts with 165 and he gains 3 followers per day. It's going to be 165 plus 3x. And now Y for Reese, well, he starts with 537 followers, but he loses 2 followers per day. So that's going to be minus 2x. And now if we start looking through our different options, well, we see that only one of them will give us the result that we found, and that's going to be B. There we are. Okay, so last question of the multiple choice section here. So question 15. So the scores on an examination are normally distributed with a mean of 70 and a standard deviation of 6. So Michael received a score on the examination between the lower quartile and the upper quartile of the scores. So which shaded region most accurately represents where Michael's score lies? Okay, so we need to remember our empirical rule here. So what the empirical rule states is that within one standard deviation either side of the mean, we have 68% of all of the data. And then if we start thinking about, well, what about between Q2 and Q3? Well, between the lower and upper quartile, you'll have 50% of all the data. So what that means now is that it's clearly not going to be B, because that is from -1 standard deviation all the way up to 1 standard deviation above the mean. So that would be 68%, and that is not the 50% that we're looking for. So it's not B. It's clearly not going to be C either, because that's going beyond standard deviations. And it's not going to be D because, well, that's just a little bit preposterous, right? It's just saying that it's everything above the mean there, so it's not D. And if we look at A now, we can pretty much see that it's going to be, yep, that's 50% of all the data within the focus on the mean, and then there's going to be that little bit of extra space either side to then add it up to be 68% of all the data if you keep going towards the standard deviations. So yeah, it's going to be A for our option there. Okay, let's get started with question 16 now. So onto the extended response section. Okay, question 16. So a bowl is in the shape of a hemisphere with a diameter of 16 centimeters. So what is the volume of the bowl correct to the nearest cubic centimeter? Okay, so the volume of, let's say, a sphere normally is 4/3 pi r cubed. That's an r. So if it's going to be half of a sphere, so a hemisphere, all we do is we times that by a half. Okay, so noticing that they've given us a diameter of 16, that means our radius is equal to 8 centimeters. And if we start computing this, well, we get a volume that's going to be equal to 1,072 centimeters cubed, correct to the nearest cubic centimeter. Okay, question 17. So the diagram shows a triangle with sides of length x centimeters, 11 centimeters, and 13 centimeters, and an angle of 80 degrees. So using the cosine rule to calculate the value of x, correct two significant figures. So our cosine rule, let's just write it out in the generic form, is normally given as c squared equals a squared plus b squared minus 2ab cos of c. So it's a little bit of a mouthful there. So the important thing to note here is that the angle C is the internal angle between the two sides A and B. And that's exactly the situation that we can see in this problem here. Okay, so now substituting in our values, and I'm just going to go ahead and take the square root of both sides. And then we see that x is going to be equal to the square root of, let's say A is going to be 11, so 11 squared, plus B is now 13, so 13 squared, minus 2 times 11 times by 13 times by cos of 80 degrees. Okay, and so when we calculate that, we get that the value of x is closest to 16 centimeters, and that's correct to two significant figures. Okay, moving on to question 18 now. So Andrew, Brandon, and Cosmo are the first three batters in the school cricket team. In a recent match, Andrew scored 30 runs, Brandon scored 25 runs, and Cosmo scored 40 runs. What is the ratio of Andrew's to Brandon's to Cosmo's runs scored in simplest form? Okay, so what we'll consider first of all, let's quickly write down the rate that it's in, so A to B to C. Keep it real simple for now. And now we look at their different values. So if Andrew scored 30, and Brandon scored 25, and Cosmo scored 40, okay, so these are all going to be divisible by 5. So then we can simplify this ratio to be 6 to 5 to 8. And that's our answer there. That's the ratio in simplest form. So part B asks us, in this match, the ratio of the total number of runs scored by Andrew, Brandon, and Cosmo to the total number of runs scored by the whole team is 19 to 36. So how many runs were scored by the whole team? Okay, so if it's 19 to 36, then we know how many did that 19 make up? So in that 19, we know that Andrew scored 30, we know that Brandon scored 25, and we know that Cosmo scored 40. So adding those all up, we find that 19 is representative of 95 runs. So if we want to figure out how many runs are in 36 components of this whole, well, all we would do now is we would say that 36 is now going to be equal to 95 divided by 19 times by 36. And that will show us the components in 36. So in other words, how many runs were in 36. And when we calculate that, we find that the total number of runs scored by the whole team, we'll write that out. We'll say runs scored by the whole team is equal to 180. And there we are. So that's our solution there, or one of the methods by which we can solve it. There's going to be a few different methods for these types of problems, just depending on how you'd like to actually think about these questions and approach them individually. So another, more general form of looking at these questions, again, would be to look at saying that the 19 is equal to the, 19 components is going to be equal to 30 plus 25 plus 40. So what many people would write is they'll just say that 19x is going to be equal to 30 plus 25 plus 40, or 95. And then they divide both sides by 19, and they say x equals 95 on 19 is going to be 5. And then they just say 36 times by x is equal to 180. Both ways are 100% okay, so whichever one you feel more comfortable with doing, then that's completely okay. All right, now question 19. So the heights in centimeters of 10 players on a basketball team are shown. So is the height of the shortest player on the team considered an outlier? So justify your answer with calculations. Okay, so what we need to do first is determine our different quartiles. So let's count up how many different players there are. Well, there's 10 players, they've already given us that. So then we know that we'll find Q1 and Q3 respectively. That's going to be at the 185 and the 194. So that's our Q1 and Q3. So let's think about what's the formula for determining if something is going to be an outlier. So if it's on the lower end, then we know it's an outlier. So it's an outlier if it's less than Q1 minus 1.5 IQR, so the interquartile range. And so just a reminder that the interquartile range is Q3 minus Q1. So we can continue this. So it's an outlier if, so what's Q1? It's 185. Then minus 1.5. So our interquartile range, as I said, Q3 minus Q1. Or 185 minus, so I'm going to write that as 3 over 2 times by 9. And so when we calculate this, well, we see that it's going to be an outlier if it's less than 171.5. And so now we look at this, the shortest player. So it's 170 centimeters tall. So we can say, yes, they are an outlier since 170 is less than 171.5. And that's our answer there. Now, question 20. So a roulette wheel has the numbers 0, 1, 2, all the way up to 36, where each of the 37 numbers is equally likely to be spun. So if the wheel is spun 18,500 times, calculate the expected frequency of spinning the number 8. Okay, well, since it's an arbitrary number, it doesn't really matter. So we know that it's going to be the chance of 1 over 37. So what we would do is we'd just say 18,500 times by 1 over 37, and that just simply gives us a value of 500. And that is the expected frequency. Okay, moving on to 21. So a person owns 1,526 shares with a market value of $8.75 per share. The total dividend received for these shares is $1,068.20. So calculate the percentage dividend yield. Okay, so to calculate the total percentage dividend yield, what we need to do is we need to look at the amount of the dividend that's been paid to us, and then divide that by the value of the actual shares themselves. So the total value of the shares is 1,526 times by $8.75. And what we also need to do, since it's going to be in percentage, is we'll multiply that by 100. And then our answer there for question 21 is just going to be 8%. Nice and easy. Okay, question 22. So two right-angled triangles, ABC and ADC, are shown. So it asks us to calculate the size of angle theta correct it to the nearest minute. Okay, so what we can do here is, first of all, let's see what we've got. So we've got AD, we know DC, and we also know AB. So what I think is probably the best thing to do is to figure out the side length AC. And so we can just use Pythagoras' theorem to solve for that. So we can say that AC is equal to the square root of AD squared plus DC squared. So 2.5 squared plus 6 squared. And we find that that value is about 6.5. So now we can label our diagram there. So we know that AC is 6.5. And now if we just want to work out our angle theta, well, let's have a look at this triangle. Let's just look at ABC. I'm going to draw it out a little bit differently. I'm going to draw it out like that. So we know that we have a right angle there, so that's going to be B. We know C is over here, and we know A is up here. So this is just the same triangle, ABC. I've just drawn it out a little bit nicer for us to look at. So we know we're looking for angle theta up here. We know that A to B is 4.9 centimeters, and we know that A to C is 6.5 centimeters. So now we see that we're just working with a right angle triangle, and we just want to work out an angle. So our best option is going to be to use SOHCAHTOA. So what side lengths do we have with respect to the angle here? So we have our adjacent side, and we have our hypotenuse. So clearly we'll be using cos. So what we can say then is that cos of theta is equal to 4.9 divided by 6.5. So now taking the inverse cosine of both sides, we find that theta is now equal to, so cosine inverse of 4.9 over 6.5, and correct it to the nearest minute. That is going to give us 41 degrees and 5 minutes. And that's our answer for question 22. Okay, now question 23. So a set of bivariate data is collected by measuring the height and arm span of 7 children. The graph shows a scatter plot of these measurements. So it asks us to calculate Pearson's correlation coefficient for the data, correct to 2 decimal places. Okay, so this is pretty straightforward calculator work. You just need to turn your calculator into stats mode, input the data, and then extrapolate the Pearson correlation coefficient. And when we do that, we get a value of r equals 0.98. Okay, so part B asks us to identify the direction and the strength of the linear association between height and arm span. Well, it's a pretty strong correlation because it's very, very close to 1. And just remembering that a Pearson correlation coefficient of 1 is the maximum. So we'd say that it's a strong. And now look at the direction of it, it's going up, so it's positive. So it's a strong positive correlation. And that's our answer there. Now part C says the equation of the least squares regression line is shown. So we have height equal to 0.866 times the arm span plus 23.7. So if a child has an arm span of 143 centimeters, calculate the predicted height for this child using the equation of the least squares regression line. Well, pretty straightforward. So h for height is equal to 0.866 times by, so the arm span is 143, and then we just add on 23.7, and that's just straightforward calculator work. So we get a height of about 147.538 centimeters. And there we go. So that's part C. Question 24. So Amanda uses 80 kilocalories of energy per kilometer while she is running. She eats a burger that contains 2,180 kilojoules of energy. So how many kilometers will she need to run to use up all the energy from the burger? And give your answer correct to 1 decimal place. And we know that 1 kilocalorie equals 4.184 kilojoules. Okay, so what I would do first is I would convert the amount of energy in the burger into kilojoules. Kilocalories, I should say. So we'll take 2,180 kilojoules and we will divide that by 4.184. And so we get a value of about 521.03 ... we'll just cut it off there. And now if she uses 80 kilocalories of energy per kilometer, Well, we will simply divide that by 80 to find out how many kilometers she needs to run. And we get an answer of 6.51. And now it's correct to one decimal place, so we'll just round that to 6.5 kilometers. And that's question 24. Question 25. A bowl of fruit contains 17 apples, of which 9 are red and 8 are green. So Dennis takes one apple at random and eats it. Margaret also takes an apple at random and eats it. By drawing a probability tree diagram, or otherwise, find the probability that Dennis and Margaret eat apples of the same color. Okay, so what we should do is, we'll use a probability tree. So let's start it off. So we know that there are two different options for the apples. So we'll have, let's say, red up there, and we'll have green down the bottom. And we know that we're going to have two branches for this, for the two different people of Dennis and Margaret. So this is also going to be red, this is green, red, and green there as well. Okay, so if we're looking at Dennis taking one apple at random first, and then Margaret takes an apple. So now we know that there's 9 red, 8 green initially. So that means for Dennis to take a red, he has a chance of 9 out of 17 to do so. So if he then takes a red, let's not forget that there's going to be one less red apple in the mix. So that means for Margaret to then pick a red apple after Dennis already picks a red apple, she'll have a chance of 8 over 16 to do so. And so now we can go through here, and we know that, well, that means that this will also be 8 over 16 for 8 green out of the 16 possible. And now we can start looking at the tree where Dennis initially took a green apple. So the chance of him taking a green apple initially are 8 out of 17. And so again, if Margaret is to then pick a green apple, that means there's a chance of 7 out of 16, which means that for her to pick a red after Dennis has picked a green is now 9 out of 16. Okay, so now we have our complete probability tree diagram. So now we want to find the probability that Dennis and Margaret eat apples of the same color. Okay, so if they're the same color, that means we're going either red, red in this path, or we're going to be going green, green. So now let's compute the probability of those two different sections there. So if it's red, red, that means it's 9 over 17 multiplied by 8 over 16. Okay, and then if it's green, green, then we know that that's going to be 8 over 17 times by 7 over 16. And so that will give us 72 over 272 up the top. And down the bottom, we have that is equal to 56 over 272. So all we need to do now is we just need to add those two values together. So 72 over 272 plus 56 over 272. When we add those, we find that that probability, so I'm going to draw that out as in using some set notation. That probability is going to be equal to 8 over 17. And that's in simplest form. Okay, and if you don't need to worry about this notation here, you can just say probability equals 8 over 17. That's completely fine as well. Okay, question 26. So, a project requires activities A to F to be completed. The activity chart shows the immediate prerequisites and duration for each activity. So part A is asking us, by drawing a network diagram, determine the minimum time for this project to be completed. Okay, so let's have a quick look. So we have activities A, B, C, D, E, F. We can see their immediate prerequisites and how long each of them take. Okay, so just by looking at our table here, well, we see that we have to start with A, and we know that A is going to be going into B, and it's also going to be going into C. All right, and now let's see what else is happening. So we know that D comes from B, and then we know that E comes from both C and D. So I might draw E over here. And then lastly, F comes from E. Oops, there we are. Okay, and the duration in hours, what we should do is we should probably just write the typical little boxes above it. That will tell us the earliest starting time and then the duration. So typically it's normally the earliest starting time and the latest starting time, but for a problem like this, we'll change it to the EST and the duration. So the earliest starting time for A will be 0 with the duration of 2 hours. So let's have a look at B. So that has an earliest starting time of 2, and that has a duration of 6. Okay. So then for D, we have an earliest starting time of 8, since it's the 2 plus 6, and the duration of D is 2. Now we can start looking at A to C. So again, we need to look at the earliest start times. So the earliest start time for C is 2, and the duration of C is 5. And now we can look at E. And so for E, well, we need both D and C to be completed. So let's just see which path will take a little bit longer. So if we go A, C, complete, that will take 2 plus 5, so it'll be 7. And if we go all the way up to complete D, well, that would take 10. So the earliest start time for E is 10, and the duration of E is 4. And now for F, again, we look at the prerequisites and how long that would take. So the earliest start time for F is going to be 14, and it takes us 1 hour to complete that. So we can say that the minimum time is going to be 15 hours. Okay, so now part B. It asks us to determine the float time of the non-critical activity. So we see the non-critical activity, after examining this, is going to be activity C. And it has a float time of 3. So we can just write it out like that, and that's fine. Okay, now on to question 27. So Ashley has a credit card with the following conditions. There is no interest-free period. Interest is charged at the end of each month at 18.25% per annum, compounding daily, from the purchase date included to the last day of the month also included. So if Ashley's credit card statement for April is shown with some figures missing, it's asked us to find the minimum payment. So the minimum payment is calculated as 2% of the closing balance on 30th of April. So let's calculate that now. Okay, so what we want to do is we probably want to find out the total amount that she's owing on the 30th of April. So we know that she has no other payments required on this card from the 1st of April, from the beginning of the month. There's no amount due. So we have a lovely 0 amount there. But then on the 20th, she's purchased some furniture for $3,700. So we're going to be using our compound interest formula here. So our P is going to be 3,700. And now we have 1 plus R, so the rate is 0.1825, but that's per annum. So we want to make that down into the daily rate. So we'll divide that by 365. And now we take that to the power of n times t. So n is the number of compounding periods per year, so that's 365. And t is the number of years that have actually gone by. So from the 20th of April to the 30th of April, and don't forget, it's inclusive of the day that you purchase it. So that'll actually give us 11 days out of 365. And so you can see that we'll end up being able to simplify that index there to just being 11. Okay, so now when we calculate that final amount, it's going to give us $3,720.40. Okay, so the minimum payment is calculated as 2% of the closing balance on the 30th of April. So all we need to do here is figure out, well, what's 2% of $3,720.40? So what we can do is just times that by 0.02, and that gives us a minimum payment. I'll just write MP as equal to $74.50. $2.41. And that's our answer to question 27. Okay, question 28. The formula below is used to calculate an estimate for the blood alcohol content, BAC, for females. So the number of hours required for a person to reach 0 BAC after they stop consuming alcohol is given by the formula time equals BAC divided by 0.015. So the number of standard drinks in a glass of wine and a glass of spirits is shown. So wine is 1.2 standard drinks and spirits is 1 standard drink. So if Hannah weighs 60 kilos, she consumed 3 glasses of wine and 4 glasses of spirits between 6:15 p.m. and 12:30 a.m. the following day. She then stopped drinking alcohol. So using the given formulae, calculate the time in the morning when Hannah's blood alcohol content should reach 0. Okay, so first of all, what we'll need to do here is use our first formula to figure out the blood alcohol content as soon as she stopped drinking. So looking at this, so N is the number of standard drinks, H is the number of hours, M is the mass of the person, so 60 kilos here. So let's figure out the BAC for a female, or for Hannah, we should say. Okay, so 10 times the number of standard drinks. So how many standard drinks did she have? So she had 3 glasses of wine and 4 glasses of spirits. So let's note that they're not the same standard amount of drinks. So 3 glasses of wine would be 3.6 standard drinks, and 4 glasses of spirits is 4 standard drinks. So all up, she had 7.6 standard drinks. So then, minus 7.5 times by H. So H is the number of hours that they were drinking for. So if she started at 6:15 p.m. and stopped at 12:30 a.m. the following day, well, that's a difference of 6 hours and 15 minutes. So if we were to write that out as a decimal, that would be 6.25. Okay, and now divided by 5.5 times by the mass. Well, we know that she weighs 60 kilograms. So now we can compute that her blood alcohol content is going to be equal to about 0.08825. Okay, so that's the BAC. And so now we need to figure out, well, when will her BAC reach 0? So what we need to do is we need to use the second formula now, and we will simply divide this number here by 0.015, and that will tell us the hours. And so doing that, we find that it takes 5.88 hours, or in other words, it takes 5 hours and 53 minutes. So what we want to do to figure out the exact time in the day is, well, let's simply add 5 hours and 53 minutes to 12:30 a.m. And so doing that, we find that the BAC equals 0 at, it's going to be 6:23 a.m. And that's our answer there. Okay, question 29. So part of a supermarket receipt is shown. So we've got all of our info there. It says determine the missing values A and B to complete the receipt. So the key here is that for chocolates, it says that GST of 10% is included in the price of the item. So what we can determine now is that if A has the GST included in the price, that means that everything else doesn't have any GST. So what that means now is that 70 cents is equal to the GST included in item A for the chocolates. So that means that if the GST is equal to 0.7, so it's 10% of what the actual item costs, well, then that means that A must be equal to $7.70, right? Since 10% of $7 is 70 cents. So what we can say now is that A is equal to $7.70. And now we know everything else, and we know that the total is $36.25. So now we can figure out how much did B cost. So for B, we know that it's going to cost $36.25 minus $7.70 minus $5, minus $8.50, minus $3.20, minus $2.85. And when we calculate all of that, we find that B is now going to be equal to exactly $9. Now, I've spoken with many students and teachers alike, and all of them agree that this is one of the most poorly worded questions that they've ever seen on a HSC examination, mainly just due to this. This is counterintuitive, because this does not represent anything in real life whatsoever. So many people hate this question simply because of the way it's worded, myself included. So now let's finish up on to question 30. So the network diagram shows the tracks connecting 8 picnic sites in a nature park. So the vertices A to H represent the picnic sites. The weights on the edges represent the distances along the tracks between the picnic sites in kilometers. So we have each picnic site needs to provide drinking water. So the main water source is at site A, okay? So by drawing a minimum spanning tree in the space below, calculate the minimum length of water pipes required to supply water to all the sites if the water pipes can only be laid along the tracks. So essentially this problem is just a minimum spanning tree problem. So whether you want to use Prim or Kruskal's algorithm, it's completely okay. They'll both give you the correct result. So what I recommend that we start by doing is just quickly going through and at least drawing up all of the different vertices first. I think that's probably the best option for us, just in terms of making sure that everything is actually written out relatively clearly for us to then compute and draw up. So now I'm going to use Kruskal's algorithm. So I'll pick the least weighted edge, so G to F has a weight of 1. I'm going to put that in there. Now I start looking around and I see, well, there's no more 1s, so maybe let's look at the 2s. So I see G to H. That is perfectly acceptable. So we can put that in there now. And again, we continue looking around and we see if there's any other 2s, and it doesn't look like it. So the next option here is going to be the 3, and that will join C to H. Okay, and again, we continue looking around, and so are there any other 3s? Nope. Are there any 4s? Yes, there are. So A to B, well, we must end up choosing that anyway to connect to B, to A. So we'll have that there as a 4. And so again, looking around, are there any other 4s? There is C to G. But if we select that, then we'll create a cycle, so we won't do that. So now we start looking at the 5s. And so we have a few different options here. So what we'll end up doing is joining B to C with that edge 5. We'll also join H to D with that weight of 5. And then we'll also end up joining H to E with the weight of 5. And so now we see that all of the vertices are connected, and we can calculate the minimum length by adding up all these different weightings here. And so the minimum length must therefore be 25 kilometers. Okay. Now for part B, it asks us, one day the track between C and H is closed. So state the vertices that identify the shortest path from C to E that avoids the closed track. Okay, so let's look at our original diagram here. So we know C to H no longer exists, and we want to go from C to E. So we're going to get from here over to here. Okay, so we start looking at our different paths. So if we go CD to DE, that's 7 plus 5, that's 12. Let's start looking elsewhere. So if we go C to G, that's 4, and then maybe G to H, that's 2, so that's 6 all up, and then a 5 to get to E. So that would be 11. So far, C, G, H, E is the best path. What about if we went C to G to F to E? That would be 4 plus 1, that's 5, and then plus that 7, that would be 12. So we see that our best option would in fact be C, G, H, E. And we'll add that in there now. So C, G, H, E. Okay, now on to question 31. So, a rectangle has width W centimeters. The area of the rectangle A in square centimeters is given by this equation here. So A is equal to 2W squared plus 5W. So the graph of A equals 2W squared plus 5W is shown. So part A asks us to explain in this context why the model of A equals 2W squared plus 5W only makes sense for the bold section of the graph. So what we see here is that on this bold section, well, it's only bold from above 0 on the w-axis and also on the a-axis. And that makes sense because, well, we can only have positive lengths and areas, in fact. So you can't really ever get a negative length or a negative area. So that's our explanation for part A. Okay, for part B now. So we have that the area of the rectangle is 18 centimeters squared, and now it's asking us to calculate the perimeter of the rectangle. So we can use our graph here, so we know that when it's 18, well, that occurs around here. So we go across, and that's when W equals 2. So we know that if the area is 18, then the width is going to be equal to 2. But I also know that the area can be given by the width times by the length. So if I was to just draw out a simple rectangle here, we'd say that's the width and the length, and clearly the area is given as the multiple of the two. So what does that mean now? That means now that if the area is equal to 18 and we have a width of 2, then that means that L, the length, is going to be given by 18 over 2, or 9 centimeters. Okay, so now that we know the width and we know the length, well, we can calculate the perimeter of this rectangle. So we know that the total perimeter is going to be equal to 2 times the width and 2 times the length, just accounting for 1, 2, 3, 4 different sides. Okay, so that means that we'll end up with a total perimeter of 22 centimeters. And that's our answer for part B. Moving on to question 32. So the table shows the income tax rates for the 2018-2019 financial year. So the Medicare levy is calculated as 2% of taxable income. So for the 2018-2019 financial year, Charlie pays a Medicare levy of $1,934.80. So what we need to do now is calculate the tax payable on Charlie's taxable income. Okay, so what we need to do first is figure out how much income did he have. So let's figure out the taxable income. So the taxable income is going to be given as 50 times by the Medicare levy of 1,934.8. And the reason that it's times by 50 is because we know that the Medicare levy is 2% of the total, and so 50 times by 2% gives us 100%. So that gives us the total taxable income. Okay, and so then we find that Charlie earned a total of $96,740. Okay, so now we just need to figure out, well, how much tax is payable on this income of $96,740. So firstly, his tax bracket is this one, right, the second from the bottom here. And let's think about that formula there. So that means that the tax is now going to be equal to $20,797 plus 37 cents. So I'm going to write that as 0.37. We'll convert that to dollars now rather than later, for each dollar over 90,000. So what we'll do there is write this out now as 96,740 minus 90,000. Okay, and when we calculate that, we find that we have an answer of $23,290.80. That's our final answer there. Okay, moving on to question 33. So the time taken for a car to travel between two towns at a constant speed varies inversely with its speed. So it takes 1.5 hours for the car to travel between the two towns at a constant speed of 80 kilometers per hour. So calculate the distance between the two towns. Well, if we're traveling at 80 kilometers per hour for 1.5 hours, that means that they are 80 times by 1.5, or 120 kilometers away from each other. And that's our answer to part A. So we know that if they're 120 kilometers from each other, what we can do now is look at how long it will take them for different speeds. So by first plotting 4 points, draw the curve that shows the time taken to travel between the two towns at a different constant speed. So, well, we know, firstly, that if it's 80, well, we know that it took 1.5 hours. So we can go and put that in right around there. What about if you're traveling at 60 kilometers per hour? Well, that would go and take us 2 hours. So 60 goes into 120 twice. Now, if we're doing 40 kilometers per hour, 40 goes into 120 3 times. And now if we're traveling at 20 kilometers per hour, 20 goes into 120 6 times. So that would go right around there. So now we've got 4 different points. So what we can do is try and construct roughly the hyperbolic function. It would look a little bit like that. And that's our answer to part B. Okay, question 34. So the relationship between British pounds, P, and Australian dollars, D, on a particular day is shown in the graph. So we have British pounds on our y-axis and Australian dollars on our x-axis. So part A asks us, it says, write the direct variation equation relating British pounds to Australian dollars in the form P equals MD and leave M as a fraction. So this is just a straight line equation, essentially. So P equals MD, where M is going to be our gradient. So gradient is just rise over run, so we notice that we go up 4 as we go across 7. So we get 4 over 7 D. And that's part A sorted. Okay, part B. It says the relationship between Japanese yen and Australian dollars D on the same day is given by the equation y equals 76D. So now it asks us to convert 93,100 Japanese yen to British pounds. So what I'd like to do here is work firstly with this a little bit algebraically. So what we can do is construct these as 2 different equations, and now we'll work with equation 2 and solve for D. So we can say that the Australian dollar is equal to the Japanese yen divided by 76. And so what I can do now is I can sub that value of D back into the first equation. So now I find that British pounds is equal to 4 on 7 times by, and now replacing D with y over 76, and then letting the fact that y equals to 93,100. So what we get then is that P, the British pounds, is going to be 4 on 7 times by 93,100 on 76, and that will end up with an answer of 700 pounds. And that's our answer for part B. Now, moving on to question 35. So a compass radial survey shows the position of 4 towns, A, B, C, and D, relative to point O. So the area of triangle BOC is 198 kilometers squared. So calculate the bearing of town C from point O, correct to the nearest degree. So just a quick reminder on bearings. So that means we start from the north line, from O, and go clockwise around until we hit that line joining O and C. And so we're looking for that angle there. Okay, so we know that from north to OB is 125 degrees. So what that means for us now is that we just need to figure out this little distance, angular distance there from line OB to OC. So to do that, what we need to do is we need to remember, how do we figure out the area of a triangle? Well, the formula is given as half AB sine C. So C is our internal angle between 2 side lengths. So for example here we have 16 kilometers and 25 kilometers. So the internal angle between those 2 sides is this angle there. And that's exactly what we're looking for. So we also know the area. So what we can do now is rearrange and solve for our angle C. Okay, so we know that 198 is the area, and it's going to be equal to 1/2 times by 16 times by 25, and then again times by sine of the angle C. So half times 16 is 8, 8 times 25 is 200, so then we get 198 equals 200 sine of C. So rearranging again for sine of C, so we divide both sides by 200, and then we'll end up with sine of C equals, so 198 over 200, we can simplify that as 99 over 100. And now all we need to do to figure out that angle there is take the sine inverse of both sides, and we get that C, that angle there, is equal to sine inverse of 99 over 100. And that will give us an angle of about 82 degrees. Okay, so what we need to do now is to figure out the entire angle from the north line all the way around to that line of OC. All we need to do is add up the angles of 82 degrees and 125 degrees. So then our final step in this problem is we'll say bearing of C from O is 82 degrees plus 125 degrees equal to 207 degrees. And we'll put that in its own little box because that's pretty much the final answer there. Alright, moving on to question 36. So a small business makes and sells birdhouses. So technology was used to draw straight line graphs to represent the cost of making birdhouses, C, and the revenue from selling birdhouses, R. So the x-axis displays the number of birdhouses, and the y-axis displays the cost/revenue in dollars. So part A, how many birdhouses need to be sold to break even? So breaking even is when the revenue is exactly equal to the costs. So there's zero profits. And we find that that's exactly at that point there when we sell exactly 20 birdhouses. So we can say 20. Now for part B, by first forming equations for C and R, determine how many birdhouses need to be sold to earn a profit of 1900. Okay, so we want to create two linear equations. So we know that the general form of a linear equation is y equals mx plus b. So b is our y-intercept and m is our gradient. So let's do this for R, the revenue, first of all. So we'll say that revenue is equal to, well, the y-intercept we know is 0, so that makes our life a little bit easier there. Now, for the gradient, let's just use our simple rise over run formula. So the rise, let's just work to this point here when x is 20. So we know that we've gone up to about 800 over 20. And that's our formula for the revenue there. So 800 over 20, well, we can simplify that as just R equals 40x. Okay, so that's our equation for the revenue. Now let's look at the equation for the cost. So for the cost, we see that we actually do have a y-intercept, and in fact that y-intercept is around 500. So right off the bat, we know that we'll be putting in a plus 500 there. So again, using the rise over run to figure out the gradient from this point to this point, well, we go up by a total of 300 over 20. And that's our equation for C, the cost. And again, we can simplify that, so 300 divided by 20 gives us 15. And therefore we have our cost formula as 15x plus 500. So now we have created the equations for the cost C and revenue R. Now we just want to determine how many birdhouses need to be sold to earn a profit of $1,900. So for us to earn a profit of $1,900, that means that the difference between the revenue and the cost is $1,900. So in other words, R minus C equals 1900. But now, rather than working with R and C, we'll convert them into the other forms of their expressions. So we can write that now as 40x minus 15x minus 500 is equal to 1900. So just be careful with that minus 500. Since we are subtracting the entire cost formula, it's going to be minus 15x and minus 500. So now rearranging this a little bit and collecting like terms, we find that we'll have that 25x is equal to 2,400. And then dividing both sides now by 25, we get that x, the number of birdhouses sold to earn $1,900 profit, is going to be 96. And that's our answer for question 36b. Okay, question 37. So a new car is bought for $24,950. So before I even read the rest of the question, we know that P equals 24,950. So each year, the value of the car is depreciated by the same percentage. Okay, so the table shows the value of the car based on the declining balance method of depreciation for the first 3 years. So it asks us now, what is the final value of the car at the end of 10 years? So in order for us to figure this out, well, we know the initial, we're looking for the final, and after 10 years, so therefore we know the number of periods. So the one thing that we don't know is the rate. So we can figure that out using some of the information presented in the table here. So because we know that it will follow this general formula of the final amount is equal to the principal times by 1 minus r, all to the power of n, t, and r is over n, although generally for declining balance problems, n is just going to be equal to 1. So you generally don't have to worry about that. Okay, so now what we know is that after 1 year, we have $21,457, and that's going to be equal to 24,950 times by 1 minus r. And we know that it's after 1 year, so t is just 1. So in fact, we don't really need to worry about that at all. So now rearranging and then solving for r. What we'll end up with is that r is going to be equal to 1 minus 21,457 over 24,950. Oops, there we are. And we can rewrite that now as 0.14, or about 14%, if you rather. So now to figure out the value of the car after 10 years, what we want to do now is again use the exact same formula. So A equals, so P, our principal, was 24,950 times by 1 minus R, we now know is 0.14, and now to the power of 10. And so now putting those numbers into our calculator, well, we find that the final answer for question 37 will just give us a value of $5,521.47. Okay, so now moving on to question 38. So in a particular country, the birth weight of babies is normally distributed with a mean of 3,000 grams, so right off the bat, mu equals 3,000. So it is known that 95% of these babies have a birth weight between 1,600 grams and 4,400 grams. So one of these babies has a birth weight of 3,497 grams. So what is the z-score of this baby's birth weight? So to figure out the z-score, we need to know the standard deviation. And so we can actually get that because we know that according to the empirical rule, within 2 standard deviations of the mean, we will hold 95% of the data. So to figure out what the standard deviation is, well, we know that, as I said, 2 standard deviations will give us the distance from the top end, 4,400, to the mean of 3,000. And so therefore, we get that 2 sigma is equal to 1,400, or in other words, sigma equals 700. So now calculating our z-score, we use the formula z equals x minus mu over sigma, and we get that z is now going to be equal to 3,497 minus 3,000 divided through by 700, or in other words, z is just going to be equal to 0.71. And that's our answer there. Now, question 39. This one is a little bit of a doozy of a question. It's 5 marks. So 2 netball teams, Team A and Team B, each played 15 games in a tournament. For each team, the number of goals scored in each game was recorded. The frequency table shows the data for Team A. So the data for Team B was analysed to create the box plot shown, and that's what's written over here. And I'll just quickly highlight, this is our median at 27. It's not very clear on this. So compare the distributions of the number of goals scored by the 2 teams. Support your answer with the construction of a box plot for the data of Team A. Okay, so the first problem here is going to be constructing that box plot for Team A. So the first things that we can note is the highest value, so we have 28. So we know that the stems, or the whiskers, I should say, will go out to 28, and they'll also go down to 19. So that means we know that we're bounded somehow between 19 and 28. Okay, so what we need to do now is look at the different data. So we know that there was 15 games in total. And what do we know about a box plot? A box plot says that the median line is given by that line that goes through that box. Doesn't have to be right there in the middle. And this isn't actually for Team B, but I've just kind of highlighted that because it's a little bit harder to see. And for the ends of the box, so that there represents Q1, and that there represents Q3. So all the box and whisker plot shows is the different quartiles, or essentially the 5-number summary for a data set. So you can actually input this data into your calculator in order to figure it out, and it can just give you all the answers. Or what you can do is you can go through and think, well, if there's 15 games in total, then I know that the median must be on the 8th score. So that means it's going to be on, let's see, so 1, 2, 3, 4, 5, 6, 7, 8. So the 8th score is 26. So that means Q2 must be 26 for our team A. So that's the line that will go through the middle of that box. Okay, so now what we need to do to figure out the different quartiles is, well, Q3. Again, we start looking at separating it into halves. So you can go from the half of the 8th score to 15, and what we'll get is that it will go up to 27. And so we can then construct that Q3. And then for Q1, well, according to the same sort of formulation, we go down and we find it at 23. And I'll draw that in there for us now. And then we can draw in our whiskers appropriately as shown there. Okay, so it's not the neatest box plot ever drawn, but it does have all the relevant information there. So we have Q1, Q2, and Q3 represented pretty clearly. So now it says compare the distributions of the number of goals scored by the two teams. So there's a few different things that we need to discuss. And so we'll just go through them one by one. So the first thing is going to be the central tendency. So what we can say is that Team B scores more goals in general, since they have a higher median. Okay, and we can see that. So Team A has the median of 26, and Team B has a median of 27. All right, so what about the spread of the scores? Well, we also see that B has a higher spread. So what we might want to say is Team A is more consistent with the number of goals scored. Okay, since they have a smaller IQR and range. Okay, cool. So one of the last things that we can say is about the skewness. So looking at the skewness of these, well, we can see that Team A is negatively skewed, meaning that the majority of the data for Team A is up to the right end of this. And then we see that Team B it's very, very slight here. So we would say it's slightly positively skewed. And there we are. So that's everything that you would need to write to get the full marks on question 39. As I said, it is a bit of a doozy of a question. Not many people actually did get full marks in their proper HSC when this was sat a few years ago. Okay, moving on. Question 40. So a museum is planning an exhibition using 5 rooms. So the museum manager draws a network to help plan the exhibition. The vertices A, B, C, D, and E represent the 5 rooms. The numbers on the edges represent the maximum number of people per hour who can pass through the security checkpoints between the rooms. So part A, what is the capacity of the cut shown? So we have a line just going through as such. And so what we need to consider is when we're counting the capacity of the cut, well, we do not count the inputs and outputs, okay? So what we see is that from B, the output is measured in the 130, but we have 40 going into B, so we don't count that input there. So the capacity of the cut then is going to be 130 plus 90 plus 70, or 290. So we do not count that 40 there. Okay, now moving on to part B. So the museum manager is planning for a maximum of 240 visitors to pass through the exhibition each hour. By using the minimum cut maximum flow theorem, the manager determines that the plan does not provide sufficient flow capacity. So draw the minimum cut onto the network below and recommend a change that the manager could make to one or more security checkpoints to increase the flow capacity to 240 visitors per hour. So looking at a minimum cut, what we want to do is let's just start looking what different cuts can we make. Well, we can start maybe through 80, 90, and 70. We could also go through 130, 165. We could also know that the ends are 240. We could also note we could go through maybe like that. There are many, many different cuts that you probably can explore. And so for us to actually end up with the correct cut, what we need to do is we'll end up starting through the 80, we'll go through the 40, then the 65, and then the 40 again. And it might take you a little bit of trial and error to figure out that that is the minimal cut. And so what we see then is that we'll have a maximum flow of, well, let's calculate it. So 80 plus 40 is 120, plus 65 is going to be 185, plus 45, that means we'll have a maximal flow of 230. So we're only 10 visitors short from what the goal is. So what we can do as a recommendation is we might just want to say increase flow from C to B by 10. And that will solve it. That will solve our problem of the maximal flow and increasing that so that way we can reach capacity of 240. Okay, moving on now to question 41. So a map is drawn on a 1 centimeter grid paper showing the positions of a supermarket and a cinema, and we also have a reservoir there. So in part A, it takes 10 minutes to walk in a straight line from the cinema to the supermarket at a constant speed of 3 kilometers per hour. Show that the scale of the map is 1 centimeter equals 100 meters. So each of these squares is 1 centimeter. So what we know is that if it's 3 kilometers per hour, I'll write it out like that for now, then that means that it's going to be 3,000 meters for every 60 minutes. Okay, but if I'm traveling for 10 minutes only, what I'll do is I'll just multiply that by 10 now, and that will end up giving us a value of 500 meters. So if we end up with 500 meters for the distance between the cinema and the supermarket, well, 500 meters is represented by 5 centimeters. So if 5 centimeters equals 500 meters, therefore 1 centimeter equals 100 meters. And that's as required, and that's part A. So now for part B. The reservoir is initially empty. So during a storm, 20 millimeters of rain falls on the reservoir. With the aid of one application of the trapezoidal rule, estimate the amount of water in the reservoir immediately after the storm, assume that all rain which falls over the reservoir is stored, and give your answer in correct cubic meters. So for the trapezoidal rule, what we should do is probably think about the different sections that we'll be using. So I would recommend this length here and this length here. And what we can do then is create a trapezoid that looks a little bit something like this. And so what you'll see is that this is going to be our height, this is going to be the length A, and this will be the length B. So now if we use our trapezoidal rule, we know that it's A equals h over 2 times by A plus B. But now let's substitute in the values for the meters, because that's what we should be measuring, meters, not the centimeters. So we know that the height is 4 centimeters, so that means it's 400 meters, and then divided by 2. A is 1 block, so that means it's going to be 100 meters, and B is 3 blocks, so that's going to be 300 meters. So what we end up then with for the area of this reservoir is 80,000 meters squared. Okay, so now we have the area of the reservoir, so we have satisfied the part where it's asked us to use the trapezoidal rule. So what we should do now is look at how much rain actually fell. So if we have a rainfall of 20 millimeters, well, what does 20 millimeters equal in meters? That's going to be 0.02 meters. So now, to look at the total amount of water that has actually been collected in the reservoir, what we want to do is we want to times the area by the height of the water that has been dropped into the reservoir. So that means that the total volume now is going to be, in meters, 80,000 meters squared times by 0.02 meters, and that will give us an end value of 1,600 meters cubed. And that's our final answer for part 41B. A little bit of a tricky problem, but if you have seen this type of problem before, then I suspect that you should be pretty comfortable with approaching this. Okay, so now on to the final question of the 2019 HSC, question 42. So the table shows the future values of an annuity of $1 for 4 different interest rates for 4, 5, and 6 years. The contributions are made at the end of each year. Okay, so there's our little table there detailing all that information. So it then says, an annuity account is opened and contributions of $2,000 are made at the end of each year for 7 years. So for the first 6 years, the interest rate is 4% per annum, compounding annually. For the 7th year, the interest rate increases to 5% per annum, compounding annually. So calculate the amount in the account immediately after the 7th contribution is made. Okay, so it's a bit of a tricky problem, but what we need to do is break this into 2 different parts of the problem. So we see that for 6 years, we have 4% interest. So what that means is we'll be working with this number over here. And so to figure out that amount in the account after the 6 years passed, all we do is we say 6.633 times by, well, how much are we adding each year? It's $2,000. So we'll say 6.633 times by 2,000, and that gives us a value of $13,266. And now if I want to figure out what happens from the 6th to 7th year, well, we have, again, so the interest rate now increases to 5% per annum, compounding annually. So what's our compound interest formula? Again, it's A equals P outside of 1 plus R over N, all to the NT. Now, everything's annually, so we don't need to worry about N here. That just remains as 1. So we can simplify this to just equal A equals P bracket 1 plus R to the power of T, the number of years. And again, now we know that it's only going for 1 year, so T becomes 1 as well, so that's irrelevant now. So now to look for the final amount, we say that the final amount A is equal to the principal amount before that year, at the end of the 6th year, of 13,266 times by 1 plus 0.05, because that's the interest rate on that 7th year. And now at the end of that year, we will then add $2,000. And so that means that the final amount for this annuity is going to be $15,929.30. And there we have it. So with that being said, that is the end of the 2019 HSC Mathematics Standard 2 paper. So whether you've gone through the entire video and sat the exam as we went through it, or perhaps you've just gone through and looked at maybe a tricky question to get a little bit of clarification, I hope it has helped. If you do have any questions, feel free to leave a comment and I'll try and get back to you as soon as I can. If you could like and subscribe, I really would appreciate that. It would mean a lot. I would love to see this channel grow. Thanks for all your support. Cheers.